Good day, everyone. Mr. Cargill here with the AutoCAD live this time. Not a brand new video as always, or as you would be used to. Alright, so what we're going to be looking at today is we're going to be going through some technical drawing, multiple choice questions. We're going to be going through the specimen paper that is on the CXC syllabus. So the questions are there and the answers are there. So you can always check, so we can cross-check our answers with our questions so that you can see that Mr. Cargill isn't just saying that the answer is A. CXC shows on the answer sheet that the answer is actually A or B or C, or whatever the answer might be. Alright, so right here, it's 60 questions. So for question 1 here, question 1 says, in an isometric sketch, circles and arcs will appear as. Good day, Alia. Alright, for this question, in an isometric sketch, circles and arcs will appear as. Would it be segments, round smooth lines, ellipses are part of ellipses, or round arcs without distortions? Any idea what the answer for number 1 would be? Alright, the answer for number 1 would actually be option C. Exactly, option C. Ellipses are parts of an ellipse, because even in AutoCAD, whenever you want to draw isometric circles, you would have to use the ellipse command. So yeah, the answer would indeed be C, ellipse. Ellipses are parts of an ellipse. Alright, so for the next question now. This next question here, number 2, says, which of the following instruments is used to draw irregular curves? Irregular curves. Yeah. Alright, so the thing with this is most of the questions are based on traditional drawing, and I think most of you would have done drawing on AutoCAD. So the questions might be a bit tricky. But yeah, for number 2, which of the following instruments is used to draw irregular curves? Irregular curves, so it would be a flexicurve. You can use a compass to draw a regular curve, but the answer is indeed a flexicurve. So both number 1 and 2 would be C. Yeah. Alright, number 3 says, which of the following drawings shows triangles of equal area between parallel lines? So triangles of equal area between parallel lines. So there are the options. So the triangles should be in equal area. Yeah. Good afternoon, Samir. Or good evening, Samir. So yeah, what would be the answer for number 3? So we have A, B, and C. So what you're looking for is triangles of equal area. So the area has to be equal, not the shape, but the area between parallel lines. So 2 things. The lines have to be parallel, and the triangles have to be equal in area. Alright, so let's look at it. Let's try to go through the process of elimination for this here. Alright. B, you can clearly see that for B, these triangles don't have equal area. Alright, so A, you're saying A. Yes, Samir, you can send it to my email. I'm going to type my email in the chat. Just give me a second. So yeah, the answer would be A. And this is why the answer would be A. The answer would be A because if we should eliminate the others, alright, so for this, you can see that this is not equal area because this part and this part, those are different. This isn't equal area because this and this, it's different. So it's 2 different triangles. for this is the same thing. This is slanted and this is a straight line, which means that these two triangles have different area. So the answer would have to be A. You can see that this section here is equal to that section. So the answer would indeed be A. And not just that, also because they have the same base. So the triangles have the same base. So triangles with the same base and the same height would have equal area. So even if this line, even if point P was like over here, as long as M and N is the same base and it went like this from M over here and then went back down to N right here, it would be equal area. All right, so that's good. Now we have, so number 3 is A. Good. So number 4 now, let's look at number 4. Number 4 is related to this question. Yes, Samir, just speak in the chat and let me know what the problem is in the chat. So it says in the drawing above, which of the following letters indicates the center of the arc, which is tangential to 2 circles? The center of the arc, which is tangential to 2 circles. Tangential means that the arc is touching 2 circles. So which one of these letters represent that point? Is it M, N, R, or O? All right, remember now, not the center of the circles, you know. The center of the arc that's touching the circles. Let me give you some time to try and figure it out. It's relatively simple though. B, sorry, point O, sorry, yeah. So C, point O, because you can see O here represents the center of the arc. All right, this is the arc that is touching 2 circles. An external tangential arc to both those circles. All right, number 5. It says here that item 5 refers to the following views. All right, so item 5 refers to these 2 views right here. Yeah. So it says, which of the views below shows the plan of the object illustrated in the 2 views above? All right. So number 5 here shows the plan of the 2 views. So the plan is what you see when you're looking down on this. So it has to be over here. Right away we know that it can't be A, because it doesn't represent, you don't see this part in A. It can't be B either because you don't see that part in B either. You see it in C and D, but it can't be D. Yes, Kajan, it is indeed C. It couldn't be D because this part should be a solid line because we're seeing this. But here it's broken, it can't be broken. It's solid here, and then this would be solid, this would be solid, this would be solid. But then you could also see the broken lines for the circle below it. So the broken lines right there and right there, so yeah. So C, so number 5 is also C. All right, number 6 says this. Which of the following correctly defines the locus of a point? All right, which of the following correctly defines the locus of a point? Is it the calculated circumference, a point which moves and traces a path, the cutting tool attached to the lathe, or a right angled triangle wrapped around a cylinder? So it's asking which one of these correctly defines the locus of a point. All right, so, and for locus, loci, that would be things like your Archimedean spirals, your ellipses, yeah, hyperbolas, parabolas, so on and so forth. Option B, number 6 is B, yeah, B. A point which moves and traces a path. Yes, so your cycloids, epicycloids, hypocycloids, all of those things are loci. Number 7 says this. Which of the following circles is correctly dimensioned? Error 1. Number 6 was indeed B. Alright, so for number 7, which of the following circles is correctly dimensioned? Is it A, B, C, or D? For this one, this is number 7. Alright. Number 7, I have the answer sheet as well. So we can look at that. Number 7 is A. And yeah, it's A earlier. So it's A because it has the arrows show you that it's from here to here. And then with the 36, you also have the symbol for diameter. Alright. This saying 36 DIA, that's not how you depict that's not how you would depict the diameter of a circle. This neither nor the R18. So it is indeed A. Yes, Olivia. Alright, number 8 says the polygon shown above is a regular. The polygon shown above is a regular hexagon of side. Oh, what's the length of one side of this hexagon? Any idea? What is the length of one side of the hexagon? And all right, let's think about it. Let's work it out. So the diameter of the circle that we use to draw the hexagon is 95. Okay, so if the diameter is 95, what's going to be the length of one side? So this is how you work it out. When you draw this circle, the diameter is 95. The radius is going to be half of 95, which is going to be 47.5. All right, and then you would use that same radius to divide your circle into 6. And that's how you would get your answer. So the answer actually is not C in this case. It is A, 47.5. All right, half of 95. So if you see a question like this and you're given the diameter, the answer is always going to be half of the diameter. Each side is equal to the radius. Yes. Yes, Alia, yes, cycle. It is indeed option A. All right, good. All right, now, so let's look at number 8. Number 9, sorry. It says, item 9 refers to the following diagram. We have A, B, and C. A has a 75-degree angle. It has a side of 100 and the next side of 75. And the question said the triangle illustrated above can be constructed with the use of a ruler and pencil only, a compass and protractor only, a compass, a ruler, and a pencil, or a set square, a ruler, and a protractor. Just by elimination, B and D are gone because you need a pencil. You can't draw something without a pencil, or you can't construct something without a pencil. So B and D would be gone. All right. A says a ruler and a pencil only. D says a compass, a ruler, and a pencil. You need the compass as well to scribe the arcs. So the answer would be C. You need a compass, a ruler, and a pencil. All right, good. So that would be number 9. Number 9 would be C, a compass, a ruler, and a pencil. All right, let's move on to number 10 now. Number 10 says, which of the following is a view of a right triangular pyramid? C, I believe that C was for the previous question. It was indeed C. All right, number 10 says, which of the following is a view of a right triangular pyramid? Is it A, B, C, or D? No. Right triangular pyramid would be this. First of all, this is a cone. All right. This is not a triangular pyramid. This is a hexagonal prism. And then this right here is a hexagonal pyramid, but we're only seeing 3 sides based on where we're looking from. All right, so number 10 would actually be C. I know why you say D, Olivia. You might say it's D because you're seeing 3 sides, right? So you think 3 sides, you think triangle, and then it's a pyramid because it comes to a point at the top. But remember, you're only seeing 1 side. All right, so the next side would have an next 3. So that would be this would have a hexagonal base. So it would be a hexagonal base pyramid. But this is a right triangular pyramid. And we can cross-reference to the answer sheet. So number 10 here is indeed C. All right, so number 10 is C. Yeah. All right, so number 11 here. It says, which of the following represents the correct procedure for bisecting an angle of 90 degrees? Bisecting an angle, one of the simplest things to do in technical drawing. No, you're bisecting an angle, not a line, but an angle. So where is the angle being bisected here? Is it A, B, C, or D? Oh, bisecting an angle of 90 degrees. So we're bisecting a 90 degree angle. So we're bisecting a 90, so we should be getting a 45. Yeah. It's B, right? Because we have we construct the 90 degree here, and then we bisect it, compass here, swing an arc, compass here, swing a next arc, draw that 45 degree line. So the answer is B. It can't be C because we don't have anywhere down here to swing the next arc from, or even over here to swing the first arc from. And over here, this is a 60 degree angle. So the answer is B. Yeah. All right, number 12 says this. It says item 12 refers to the following diagram. Which of the following represents the plan of the drawing above? All right. Yeah, yes, Samika, number 11 was indeed B. I can kind of tell that the it's a bit delayed for you, but don't worry about that. I have been tormented after choosing TD, and I believe it's the worst choice of my life. The industrial arts department at my school cannot teach, and as a result, around 200 students are at a deficit due to their incompetency, consequences of their struggle in scamming for non-essential resources for TD. I barely escaped my paper 2. However, there is no escape for the paper 1. I have not learned any. That's why the only thing that's been teaching me is this. Which is, what should I do? I'll give them the paper 1 is to. Well, all you can do if the paper 1 is tomorrow is try to, we'll just see what I'm doing on the live and try to memorize some of the answers, because more than likely it's going to remain the same. No, when I say remain the same, most of the answers are going to be the same. Okay? All right, number 12 now. Which of the following represents the plan of the drawing above? All right. So the plan. So when you're looking down on this, what would it look like? All right. So when you're looking down on this now, it is going to look like this. B. Well, that's my first glance, but let me see if I'm correct. All right. So with A. With A, it can't be this, because this has like a sharp little pointy edge here, and that's not the case. This is, looking down at this from above, it would look like a true rectangle. So it can't be A. It can't be this either because of the same thing. It has a point, and this just doesn't make any sense. It can't be this either because this over here is open. This section is open, and this is closed off. So it has to be this that has this section open, and you see the circle going through, and you see the underside and everything. So the answer for this would have to be B. All right, number 13. Which of the following patterns could be folded to form a truncated square prism? So any idea, which one of these could you fold to get a truncated square prism? Truncated just means that a piece of it is cut off. Alright? And square prism means that the base of it is a square. It doesn't have a cover, so just the four sides. You need a square prism. Any idea what the answer for this question would be? Option 13, number 13 is option A. Number 13 is A. Yeah, it is A. Because when you think about it, yeah, it is A. Because look at it like this. If you fold this, this won't meet up with this. Alright? And so it won't be perfectly square. The fact that these two wouldn't meet perfectly either, that's the next reason that it couldn't work. This couldn't work either, so the answer would have to be A. Alright? Alright, so I'm going to type my email in the chat, which is Dante Cargill, DONTAECARGILL @gmail.com. So just email me, alright, and we can talk about that after the live. But for now, I just want to focus on going through the questions, preparing people for tomorrow and so on. But after the live, after we finish going through the 60 questions, email me and I'll reply via email. All right, number 14. Which of the following drawings shows a rectangle equal in area to a triangle? All right, so a rectangle equal in area to a triangle. I think I have this video on my channel. All right, any idea what number 14 what the answer for number 14 is? Any idea? So it is a no idea? Okay. All right. Number 14 is C. C. Yeah. Number 14 is C. C. Yes, indeed. Indeed. All right, it is C. And this is why it is C. It's C because, all right, if you just eyesight it, as I said, the video is on my channel and I could show you in AutoCAD as well. But if I show you everything in AutoCAD, this would be like a 5-hour live. So I can't show you every single question. But if you just look at it, first of all, this isn't a rectangle. All right? This is a rectangle and that's a triangle. But this isn't equal area. These two pieces, they're not the same area as this and this. So that can't be the same area. And this is a square, not a rectangle. So the only option left is C. Yeah, 14 is C. Number 15 says here, which pictorial view below is represented by the orthographic views shown above? This is the orthographic views. Alright, so with these being the orthographic views, which would be the isometric view of this? So let's think about it. So there's a hole down here in the base, and there is no hole in the side in this part. So it can't be the one with two holes because this only has one hole. No, Samir, you'll be good. Just email me and you'll be fine. No worries. All right, so A, it can't be A. And the reason it can't be A is because this is a square or a rectangle. But this is, this has a curve. So it can't be A and it can't be C because C has two holes. So it has to be B. And the reason it has to be B is because this is the only one. Yes, Tamika. So this is why it would have to be B, because this is the only one where the part that has the circle also has a curve around it. So see, that has the circle, it has a curve around it. This has the one circle, but this part has a square, and then this part has a curve, which when it should be the other way around. So it's B. Number 16 says here, the purpose of the construction above, when completed, is to do what? What are we trying to do? Are we trying to draw a tangent to the circle from A, drawing a tangent to the circle from A, which I think we're trying to draw a tangent to the circle from A. B, draw two tangents to the circle from B, draw an arc to pass through 3 points, find the mean proportional to AO and CO. I think the answer is A. I think right here we're trying to find the tangent to a circle from A, but let's see what the answer sheet says. That's number 16. Yeah, it's A. Number 16 is indeed A. So what we're doing here with this construction is we're trying to draw a tangent to the circle from A. That tangent would go from A and go through C, which is the point of tangency. So it is indeed A. All right, number 17 here says, in the diagram above, the angle EFH, all right, the angle EFH, what's the measurement for that angle? What is EFH, this right here? Is it 30, 45, 60, or 90? B? Yeah, it is indeed 45. And the reason it's going to be a 45-degree angle is because it's in a semicircle, and one point is at H, one point is at E, and the next one touches a point on the semicircle. So it's 40. What am I talking about? It's 90. Sorry. It's not 45, it's 90. It's 90. All right. So once you draw a line, so let me see if I can show you this in AutoCAD. Yeah, it is 90. So let me see if AutoCAD is open over here. Yes, it is. All right. Let me see. I might have to just switch between windows. All right, let me try and switch to this scene here. Okay, that scene doesn't have that. That's just as that. All right. So I'll have to do this. Let me bring AutoCAD over here and see. All right, it's not going to do that. I'd have to restart the live, so I won't do that. But yeah, angles in a semicircle like this, it is going to be equal to 90. Okay, so it's going to be equal to 90. So as long as one of the lines start from one end and touch the semicircle, even if the line left from H and touched this point on the semicircle and went back to E, the angle there would still be 90 regardless. So that's always going to be 90. Yeah. All right, number 18. A cube with an edge of 80 millimeters is to be drawn in oblique projection. Okay? So that's a cube with an edge of 80 millimeters is to be drawn in oblique projection. The length of the receding lines in millimeters should be, let me say, the cube of an, oblique projection. With oblique projection, you have cabinet oblique projection and cavalier oblique projection. For cavalier oblique projection, it's almost like isometric, except you draw the face flat, the face of the figure flat. So if you have a cube, you draw it like a square. You draw this face as a square, and then you project the lines out at a 45-degree angle. You know, in isometric, you draw them at a 30-degree angle. In oblique, you use 45 and the face is flat. So for cabinet oblique projection, for the lines that project out at the side, instead of drawing them at the full length, you draw them at half the length. So this says that if the edge is 80, we'll draw it as 40. So the answer for this would be 40. Yeah. All right, Samuel, I'll check my email after the live. So this would be 40. All right, so the answer should be 40 for number 18, and we can cross-reference that. So D, which is indeed 40. Yeah, 40. Remember to like the live as well, and also to share it. And if you subscribe to Reach, this would be very good as well, because I do post content on this channel as well. And also, there's also content for a lot of other subject areas, SBA and stuff like that. So remember to subscribe and also to like the live as well. All right, number 19. which of the following is a true elevation of the drawing shown above? So this drawing here. Sir, do you have access to other past papers because only 2 are available on the Csec website? I had the 2017 past paper, but I've been searching for it for the live today, but I couldn't find the 2017 past paper. That's the only other one that I had. So yeah. But whatever past papers you have, just go through them, because for the most part, CXC don't really change multiple choice questions. So once you go through a number of past papers, you will more than likely see almost all of those questions back again on the paper tomorrow. All right. Number 19, which of the following is a true elevation of the drawing shown above? So of this. So what would be a true elevation of this would be, this is giving me a, yeah, because let me think about it. It has to be A, because this is the circle, and it shows that this is a circle, that you have the center line to show that it's a circle. For this, it can't be B, C, it can't be C. It can't be B either, because this part over here for B is closed, but over here it's opened. So yeah, number 18 is A, it has to be A. Number 13, which of the following illustrates, the normal of an ellipse? Normal. And the answer for this is, D. All right, so number 20 is D. It has to be D, because this shows a normal and a tangent. This shows the concentric circles method of drawing an ellipse. This shows the Trammell method, and this shows the rectangle method, but this shows how to draw a tangent and a normal to an ellipse. So the answer is D. Number 21, the spiral of Archimedes, the Archimedean spiral, very famous drawing in TD, especially if you do BMed in grade 12. All right, it says D. The spiral of Archimedes is defined as, so you say D, let me see what D. Oh, you're saying your D was for the previous question, okay. So it says a plane curve generated by a point on a third card as it is unwound. No. From the perimeter, no. The path generated by a point which revolves uniformly about a pole and has a uniform motion away from it. So the answer is B. The Archimedean spiral, if you don't know what that is, I have the video on my channel how to draw the Archimedean spiral. And it says the path generated by a point which revolves uniformly about a pole and has a uniform motion away from it. So the answer for that question would be B. Number 22, which of the following patterns can be folded to form a square prism with an oblique top? An oblique top just means that the top isn't necessarily flat or square or rectangular. It's kind of at an angle. Even if it's square or rectangular, it's at an angle. It's not like flat. All right? So it has an oblique top. So it says a square prism with an oblique top. And the answer for that would be D. All right? So you have the 4 sides, 1, 2, 3, 4, the base, and then the lid, which is oblique. This would have the base, this would have 4 sides, the lid and a base, but the lid for this would not be oblique. This doesn't have a lid. This isn't even a square prism. All right, so the answer for that was D. All right, so for this one here, number 23. So the diagram above illustrates the construction of is it circle tangential to 2 converging lines, tangent from a point outside a given circle, or is it a circle tangential to 2 lines at right angles, tangent to a circular point and circumference? So it's this. This is what's happening here is that there's a tangent being drawn to 2 lines at right angles. So right here, that's a tangent that you're drawing to these 2 lines that meet at a right angle. So the answer for number 23 is C. All right. So here now, it says, number 24. The construction used in designing the bending jig illustrated above was that for obtaining is it A, tangent joining 2 circles, B, common internal tangent, C, tangent to 2 equal circles, or D, tangent from a point outside the circle. Construction used in designing the bending jig illustrated above was that for obtaining a tangent Oh, tangent joining two circles. Yeah, tangent joining two circles. Tangent to two equal circles. Tangent from upon this other circle, common internal. Tangent joining two circles. So 24 should be A. 24 is indeed A. Yeah. Number 25 here now says, the point at which the bisectors of the angles of a triangle meet. So the bisectors of a triangle, so the bisectors of one end, one point on the triangle, the point at which the bisectors of the angles of a triangle meet is the center of, or the bisectors of the angles, oh, when you bisect the angles. Two given circles, the ascribed circle, inscribed circle, the common tangent, it's the inscribed circle. When you bisect two angles of a triangle, wherever those two lines meet, that point, if you draw a circle from that point, then that circle would touch all three sides of the triangle without going outside the triangle. And if you bisect any two sides, where those two lines meet, when you draw a circle from there, you would get a circumscribed circle that would go around the triangle, touching all three corners, without going inside of the triangle. So it would be C, the inscribed circle. Number 26 says, the type of projection illustrated above is, and I'm glad that this question is here because I can use this to explain oblique projection. So this is oblique projection. So you see the face, it looks flat. All right. This section of it looks two-dimensional. Good. And then for the sides, you have the sides going out at a 45-degree angle. So this is oblique projection. And I have videos on the Mr. Cargill channel that explains this as well. All right. Item number 27 now here. It says item 27 refers to the following construction. All right. Which of the following is true of the construction above? Is IJKF is half of the area of EFGH. So EFGH is this and then that is that. All right. EFGH is equal in area to IJKF. So yeah, this is what's happening. The rectangle is equal in area to the square. So the answer is B. So this method here shows how you draw a rectangle equal in area to a square, or a square equal in area to a rectangle. That video is on the channel as well. So the answer for this is B. Now for this next question, would have come in the written section of the SBA. I know you have different SBAs, but I think everyone would have had to do a written section that required you to learn about the different codes and standards. So I said ANSI, BS, and ISO regulations using technical drawing refers to international standards. So these are international standards. All right. So if you see this question, the answer is international standards. Number 29. When sketching pictorial figures, one should first do what? What's the first thing you should do when you're sketching something? Would it be sketch circles, draw all straight lines, construct parts separately, construct a box to hold the figure? What do you think is the first thing that you should do if you're sketching something? All right. Let me give you like a few seconds to see if anybody answers that question. So do you have access to other, or that's already? All right, the answer would actually be D. All right, you want to make a box and then you construct the figure from the box. All right, so the answer would actually be D. Yes, Alia, the box. All right, number 30. Which of the following surfaces is developed in the shape of a T? All right. So which one of the following surfaces is developed in the shape of a T by unrolling? Is it a square pyramid, a triangular pyramid, a rectangular box with a lid, hexagonal truncated prism? Which of the following surfaces is developed into the shape of a T? Oh, it's actually a rectangular box with a lid. All right. D, it said D, a hexagonal truncated prism. It's actually a rectangular box with a lid. So if you get a T, this is like this. It's like this right here. This question. This. Good? So it would look something like this. And this is what would give you a rectangular box with a lid. And we can cross-reference that. So see, this looks like a T, but it would have a lid and a base is the thing. So we can cross-reference that. So number 30, I said it would be a rectangular box with a lid, which is C for number 30. So let's see. Number 30, yeah, number 30 is actually C. Yeah. All right, number 30. Number 31 says here, the construction above shows how to draw a parallelogram equal in area to a given triangle. If EF is 30, then X is what? If EF is 30, EF from here to here is 30, what's the length of X? What is the length of X? I think it's 15. What's triangle? Half base times height. Number 31. Is it 31? It is 31. 15 is what? B? Yeah, 31 is B. 15. Half of the height. Half of the height. So if this is 30, then that's 15. Oh, the replies are lagging. Oh yeah, I realized. All right. 15 units. Yeah, correct. It would be 15. All right, number 32 says this. Item 32 refers to the following diagram. This diagram. The diagram above shows the method of finding the center of an arc with radius r, which is tangential to two straight lines meeting at right angles. This is not a right angle. Two straight lines meeting at any angle. Yeah. A line and a circle, a straight line. So this is how you would draw a circle that is, or an arc that is tangent to two lines that meet at any angle. Alright? Simply, all you have to do is offset this line by a certain amount, offset this line by the same amount. Wherever they meet, you draw the arc from there, and the arc would touch both circles smooth like that. And that's how you would get that. Alright. That was item 32. So now item 33. And item 33 refers to this diagram right here. Alright. It says the diagram above is to be reproduced in third angle projection. So we're going to be doing this in third angle. Alright. On what views can X be seen? X. For third angle, you put the left on the left and the right on the right. Alright, so we'd see X on the top view. So looking down on X, we would see it on the top view, on the right side. So it's from the top and from the right side, because it's on the right. And the right would be on the right. So it would be the top and the right side. We wouldn't be seeing it from the front. So it can't be B or C, because those have front. It can't be A either, because that has front. So it has to be B. The top, which is up here, we're looking down on the figure, you'll see that line, and from the right side, you'll also see it right there as well. So the answer for that is B. 34. It says the sides of the square QRST above. Alright? So the sides of the square QRST are bisected and the adjacent points are joined to form another square. Alright? So they are bisected and the adjacent points are joined to form another square. It says the area of the new square is, what's the area of the new square? Alright, so let's do some calculation. So that's 18 times 18. Sorry, let me do the math here. So the area of the first square would be 18 times 18, which would give us 324. So this is 324. And the next one inside is actually half the size of the first one. So the question might be, how do you know that? Once you have a square and then you draw a next square inside the square like this from the center point. So from the midpoint, connect this midpoint to that midpoint to this midpoint, then this midpoint to here, and then we finish the square by connecting that midpoint to here. What the next square that you will get is going to be half the area of the first one. So that would be 324 divided by 2, which would give us 162. I'm mean, just confirm 324 divided by 2, 162. Yeah, so the answer for that would be C, which is 162. Item 35. It says, in the diagram above, the circles and curves are shown in their true shapes. The method of projection used is, and this is the third question on the paper about oblique projection. So you see the circle is shown in its true shape, the front part, and then it goes out at a 45-degree angle. So this is oblique projection. So the answer for this is A. All right, number 36 here says, in the ellipse above, which sum of distances is equal to AB? Which sum of distances is equal to AB? So this is the length of AB. Is it F1C to F2C? So F1C to F2C, okay? Is it AC plus BC? AC plus BC is equal to, okay? If it's F2C plus CD, F2 to C plus C to D, okay? Is it F1C to CB, F1C to CB? No, the answer is the first one, F1C to F2C. Because this is how you would go about finding the focal points for an ellipse. You have the major axis, you take half the length of the major axis, so like from O to B, put your compass point at C, scribe an arc, you get F1, scribe an next arc, you get F2. So the distance from C to F2 is equal from O to B, which is half of the major axis. So the distance from here to here, then to here, is the same as the distance from A to B. So the answer is A. A station, the answer is indeed A. All right, number 37. When designing a new product, which type of drawing is usually made first? Scale, sketch, detail, engineering. I would say sketch. Because you're not going to waste the time to do the detailed drawings and the engineering drawings and everything, get everything to scale. You want to do a sketch first and see what it looks. Just like with your SBAs, where you had to do a sketch first, and that's why sketching is important. So I would say number 37 is B. So let's double check. Number 37 is indeed B. Yes, sir. Yeah. Yes, Sashani. Now, for number 38, it says the center of the circumscribing circle of a triangle can be found by using the what? And I mentioned this earlier for the one about the inscribed circle. So for the inscribed circle, inscribed means that you have a triangle and you're drawing a circle that fits inside the triangle. It doesn't go outside and it touches all three sides. For the circumscribed, it's outside, it covers the triangle, encompasses the triangle, it touches all three corners. So for that, what you would need to do is to bisect any two sides. So it says the bisector of any two sides. Yeah, so that's 38. Number 39 says, in a perspective drawing, all vertical lines, A, have vanishing points, B, pierce the picture plane, C, are towards the point of sight, are parallel to the picture plane. In perspective drawing, all vertical lines are parallel to the picture plane. Vertical lines are parallel to the picture plane. Yeah, I think 39 is D, parallel to the picture plane. Yeah, it is D. But this, I don't think perspective drawing is even really on the syllabus. It's on the CAPE syllabus, but anyway, it's a perspective drawing question. And the answer is parallel to the picture plane. It's actually A. They are parallel to the picture plane. And if any of you do CAPE, you do BMed, you decide to go to grade 12, and you're going to be doing BMed, Building and Mechanical Engineering Drawing, which is TD in 6th form. I have videos for those on the Mr. Cargill channel, and on this channel, Reach Educational Services, under all of my videos, I have a link to Reach Educational Services, we're offer tutoring for like BMed and TD. So if you're going to be needing help with BMed and so on, and other subjects as well, you can check out the links under the channel. What is a picture plane? The picture plane has the image. So it's like, I don't know, you would have done art in like grade 7, grade 8, probably up to grade 9. All right. And in perspective drawing, we have like a vanishing point. All right. Like a dot, a vanishing point, and all the points coming out from the dot. The picture plane is where the actual image is. All right. So if you're looking at a shoe, that's the picture plane where the shoe is. And in perspective drawing, the vertical lines, any lines that are going up, going vertically, are going to be parallel to the picture plane. Yeah. So yeah. So the answer for that would be D. But that's what I'm saying. Like, perspective drawing isn't even on the Csec syllabus. It's on the CAPE syllabus. So I don't understand how you have a perspective drawing question here, but yeah, that's the answer. All right, number 40 refers to this diagram. It says the diagram above shows a method of constructing is it a tangent to a circle at a point, a tangent at a point on an arc, a circle passing through a given point, circle tangential to two converging lines. What are we doing here? Tangent to a circle at a point. Tangent to a point on an arc. This is a tangent to a point on an arc, I think. Let me see number 40. What's number 40? It's actually B. Tangent at a point on an arc. Tangent at a point on an arc. So this is the arc. We have this point P, and we're drawing a tangent to point P. So a tangent to a point on an arc is number 40. All right, number 41 says, which of the following scales would be used to produce the smallest drawing of a given object? Think about it. The smallest drawing. So we have 1 to 2. If something is 1 to 1, that's its actual size. Good? If something is 1 to 2, we are drawing it twice as small. If something is 5 to 1, we're drawing it 5 times larger than its actual size. If it's 10 to 1, we're drawing it 10 times larger. So the larger the number on the right, the smaller the drawing. The larger the number on the right, the smaller the drawing. And in this case, A is the only one with 2 on the right, so that 41 would be A. Yeah, 41 is A. So the smaller the number, the larger the number on the right, the smaller the answer. Yes, so it is A. Did I just say the smaller the answer? I mean the smaller the drawing. Number 42. This says the figure above illustrates the start of the method of construction for drawing views of. Now this is the thing with this question. Most of you would have done drawings on AutoCAD. I don't know if there might be people who have not done traditional drawings at all. Once you started TD, you started with AutoCAD, and I think it's good to start with traditional drawings because paper 1 refers to traditional drawings. Now this shows the method that we would use to draw isometric circles if you were drawing them on paper with your pencil and your compass and your set squares and so on. So it says circles in perspective, circles in isometric drawing. So this is how you would go about drawing circles in isometric drawing. So number 42 is B. Number 43. Which of the following drawings represent a truncated prism? Truncated prism means that a part of it is cut off. All right. A station, the answer would have been B. I know you're referring to 42 because the answers are a bit delayed, but it would have been B. So 43 will be A. All right. So, and we know it's A. Truncated. The word truncated just means that a part of something is cut off. All right. A part of it is cut off. And these diagonal lines right here, these hatching lines, are what I use to represent something that is cut off. And that's the only one that has the cut. None of these have cut. So these are all solid. All right. This is the one with the cut. So 43 is A. On which of the following planes would the plan of an orthographic projection appear? The plan of an orthographic projection, the plan. So we're looking down. Profile, vertical, auxiliary, horizontal. The horizontal would have the front, and then the vertical would have the plan. So let me see. 44, I would say vertical. 44 vertical. 44. 44 is D. What's D? D is horizontal. Horizontal. Because we're looking down. So that's going to be, if oh yeah, it's horizontal. This is why it's horizontal. This is why it's horizontal. For 44, this is why it's horizontal plane. So you have a figure that you're drawing in orthographic. You have the, whether it's first angle or third angle. So which, depending on the angle, you'd have the front, and then you have the plan either below it or above it, depending on if it's first or third angle. And then there would be a line, an imaginary line, a XY line, between the plan view and the front view. So they're on the horizontal plane. They're on the horizontal plane because that line that separates them is a horizontal line. The sides would be on the vertical plane because the line that separates the plan and the front from the sides would be a vertical line. So those would be, the sides would be on a vertical plane, and then the plan view and the front view would be on a horizontal plane. All right, number 45 says, which of the following class of fire extinguishers can be used to put out an electrical fire? This is class C. A is regular fires, B is like flammable liquids, and then C is electrical fires. And I think these are a mixture of all the above. Which number is this? This is number 45. Number 45, yeah, it's C. So A is regular fires. Regular fires mean things that are caused, like fires that are caused by like paper, trash, pieces of wood, those regular stuff. And then B is a flammable liquid, so your methane, all of those things. And then C is electrical fires, and I think D, I don't remember what D is. Yeah, but that's A, B, and C. All right, number 46. In the drawing above, two arcs are drawn tangentially to two circles of different radii. What are the lengths of EX and CY respectively? So EX and CY. What's the length of EX and CY? EX. Okay. All right. So, and CY. Oh, so this is 50 and this is 55. So this is 55 plus 25. So this is 75. And then over here, this is 55 plus 35, so that's 85. So 80, no, it's not 85, because this is 70, so that's 35. So 55 plus 35 is 80. Sorry. 55 plus 35 is 90. What am I saying? 55 plus 35. All right. CY would be, the fires are also for combustion metals. Yeah, combustible metals. Yes, combustible metals. So CY would be, I know that CY is 55 plus 25, and that's 70. And then this is 80. 55 plus 25 is 80. Yes. So what is 80 and 1 is 75. So the answer is 80 and 75. EX and CY, 80 and 75. Yeah, so that would be the answer. So how do we know this? How do we know it's 80 and it's 75? Because this is an internal tangent. So the distance, if the distance from here to this point here is 55, we see it here, it's 55. And then the diameter for this is 70, and this goes to the center, which would be the radius, half of the diameter. So it's going to be, if this is 70, half of this is 35, so 35 plus 55. All right? And then, 35 plus, not 55. This is 35 plus 55, it's 35 plus 25. 45. And then that gives us 80 and 75 respectively. All right. Remember to subscribe as well. All right, number, and we can double check that. That's B, 80 and 75. Which number is this? 46, 80 and 75. A. Wait, 46 is A. 75 and 80. EX and CY. EX and CY. 75 and 80. Yeah, 75 and 80, because the 75 is on this side and the 35 plus the 25 is on this side. So it's 75 and 80, not 80 and 25. 80 and 75. Number 47 says, the distance between the foci of an ellipse is 24. Okay. And the length of its major axis is 18. the length of its major axis in millimeters is, no, sorry, the minor axis is 18. The length of its major axis in millimeters is what? So the distance between the foci of an ellipse is 24, okay? And the length of its minor axis is 18, okay? So 18, and then distance between the foci is 24. I would have to do it in AutoCAD, but my AutoCAD just isn't coming up to show you what the length would be. Because what I would have to do is just to draw the minor axis, draw a random line for the major axis. It's not going to be the actual length, and then use the focal points, and then we would get the answer. So let me just see what the answer is here. So 47, this is C, so 30. 30, 24 plus 6, and for the entire length. So that means that, so that's 24, so 6, so 3 and 3. So, okay. All right, so the length of the major axis in this case would be 30. All right, tolerance. 47 is C, 47 is C, yeah, 30. It says the tolerance for a shaft 18 millimeters long. Now, this is what tolerance means. All right, thank you for the subscription. All right, so this is what tolerance means. Tolerance means the amount of space that you would have left for something to fit into. So it says the tolerance for a shaft 18 millimeters long is plus 0.055 and minus 0.063. What is the correct tolerance range? So this is the correct tolerance range. So it says plus 0.055 on 18. So that's 18.055. All right. So, and then minus 0.063 from 18, whatever that gives you. So let me tell you what that gives you. So that would be 18 minus 0.063, which is 17.937. So it's from 18.055 to 17.937. So that's the answer, C. Good? So what that means is that if that's a tolerance for the shaft, so you're building something to fit that shaft into, so the shaft that you're building to fit that thing into, it can be between any of those distances and it will fit perfectly, but not larger or smaller. Yeah, so tolerance just means that you don't have to stick to one exact measurement or one exact size. Number 49 says, 3 circles of varying diameters, so 3 circles different diameters, which touch one another can be drawn if given the radii and a line, 2 lines and a point, 2 lines and a point. The position of their centers, 3 points through which they pass. 49, yeah, 2 lines and a point. So if you have 2 lines and a point, then you can use the length of 2 of the lines would be the diameter for one of the circles, and then you can use the next point as a center for the next circle, and then you can draw a circle from there to touch the other 2 circles. So the answer would be 2 lines and a point for number 49. All right, number 50 says RS is a straight line. So we know that about RS, straight line. A line segment 25 millimeters long is marked. Okay. Exterior angles of 45 degrees are marked off at each end of the line segment. Okay. The 2 angled lines formed are 25 millimeters long. If this construction is continued until a closed figure is formed, the figure obtained is... Tajay, thank you for the subscription. All right. Sir, please go over number 46. Number 46. All right, number 46. All right, so number 46 is this. EX is this here. This is an external tangent, 110. When there's an external tangent, we subtract. When there is an internal tangent, we add. So this external tangent here is 110. Good? So this is 110, and then the radius for this is 35. So this over here would be 110 minus 35. All right, so this distance here is 110. Rowan, thank you for the subscription. All right, so from here to here is 110. And if we subtract the 35, which is the distance from here to here, we get the distance from here to here. So let me do it like this. If we continue this line EX to this point of tangency, that total distance would be 110. We see it right there, that's 110. Now, if the diameter is 70, then that means that the distance from here to here is 35. So if we subtract the 35 from the 110, we are left with 75. So the distance from X to E is 75. All right, so that's 75. Now over here we have an internal tangent. And when there's an internal tangent, we add. So this is 55 plus 25, and that gives us 80. So EX is 75, and then from C to Y would be 55 plus the 25 for the radius since the diameter is 50, and that's what gives us 75 and 80. I said 50 is C and octagon. Let's see, 25 millimeters long, 45 degrees. 2 lines. All right, so number 50 is an octagon. Number 50 is an octagon. Yeah. So number 50. You continue this till you get an octagon. All right. Oh, you got it? All right, good. Glad you got it, Alia. All right, item 51 refers to the following drawing. All right. Now, it says, the drawing above shows the development of is it a pentagonal box with a lid? Is it a hexagonal box with a lid? Is it a pentagonal box without a lid? Or is it a hexagonal box with a lid? You can see the sides, 6 sides, so that's a hexagon, right? And so 1, 2, 3, 4, 5, 6 sides. With a lid or without a lid. If this is the base, it doesn't have a lid because the lid would be on this side. So it would say box without a lid. Hexagonal box without a lid. Hexagonal box, so that's D. 51, D, yeah, hexagonal box without a lid. So these 6 sides, so this is 1 side, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Those are all the sides. This is the base, but there is no lid. If there was a lid, there would be an hexagon on the top here. Number 52 says, the elevations shown above are those of a square prism, square pyramid, triangular prism, hexagonal prism. Hexagonal pyramid, hexagonal pyramid, hexagonal pyramid, hexagonal pyramid. I think hexagonal pyramid, because if we're seeing 3 on one side here, that means that there's 3 on the next side, but this here looks like we're seeing 2, so it's kind of confusing. Number 52, yeah, number 52 is D. It's a hexagonal pyramid. I don't know it's a hexagonal pyramid because we're seeing one side, so if there's 3 sides here, that means there's 3 on the next side, 3 plus 3 is 6, 6-sided figure, hexagon. Hexagonal pyramid. Prism. Pyramid, pyramid, pyramid. A pyramid goes to a point. Hexagonal pyramid. Number 53. When a plane figure has a linear reduction, only the proportions are changed. Only the proportions are changed. Nothing else. Proportion dimensions, and proportions change. The proportions change. Proportions change. I mean, number 53 says B. Proportions, no, 53 says proportions remain, proportions remain the same. Dimensions change. Proportions remain the same. So it means like this. If you have a triangle and it is 3, 4, 5, 3, one side is 3, one side is 4, one side is 5. If you have a next triangle where one side is 6, one side is 8, one side is 10, the proportions will be the same. The only thing is that the dimensions will be different. One triangle will be bigger than the other, but the proportions will be the same. It will just be a smaller version or a larger version. So the proportions remain the same. The dimensions are what change. Number 54. Which of the following drawings represent an inscribed triangle? The thing with this is that lots of people learn the Inscribed, which is this one, the triangle on the inside. This is just madness right here. Looks like the foundation, the first set of drawings for like an Avenger or something like that. C is an inscribed circle. Alright. D is a circumscribed. The circle is over around the triangle. But what a lot of people don't do is the E-scribed, or some people call it S-scribed, but it has to be E-scribed because E and then scribed. Triangle, which means that the circle is just touching one side. So the answer is A. Alright, number 55. Which is the first step that should be taken if a person receives an electric shock in a workshop? Turn off the source, activate the fire alarm, remove the person to safety, cover the person with a safety blanket. You can't turn off the source. As sad as it sounds, you can't turn off the source because you don't know if that source is going to shock you. You can't remove the person because you can't touch the person because they're going to be electrocuted. And a safety blanket could work if it was a cartoon, but it's real life. So all you can do is to call the relevant personnel by activating the fire alarm. So 55 should be C. 55 is B. Wait, 55 is B? Oh yeah, B. Activate the fire alarm. That's what I thought it was C. Activate the fire alarm. Or call, your personnel, whether it's 911, 119, whatever, depending on where you are in the world. So that's what you have to do, sadly. You might get the urge to try to remove the person, but do not do that. There will just be two bodies instead of one. Alright, number 56. In the drawing above, which of the following is not true? The line RM is equal to the line PR. RM is equal to PR. RM is equal to PR. It could be. The line DR can be of any length. DR. Well, that looks true. The angle PRM is equal to the angle RPM. PRM is equal to RP. That's not true. The angle MRMP is equal to the angle RPM. RMP is equal to RPM. That looks true. So I think the only thing that does not look true is C. Number 56 is C. Yeah, number 56 is C. Number 57, a netball court has a length of 30 meters. A line representing this distance on a drawing measures 30 millimeters. To what scale ratio is the line drawn? How many millimeters make a meter? I believe it's 1,000 or is it 100? Depending. So how many millimeters make a meter? So it's the centimeters and then meters, because 10 millimeters, 1 centimeter, so 100 millimeters makes 1 meter. If that's the case, it's 100. It's 1 to 100. If 1 millimeter is 100 meters. If 1 millimeter is 1,000, then it would be A. But if 1 millimeter is 100, sorry, if 1 meter is 100 millimeters, then it's B. All right, but let's see what it is. It's A, so it's 1,000. At 1 meter is 1,000 millimeters, so it's 1 to 1,000. Number 58,000. All right, yes, Alia, thanks. It is indeed 1,000. So which of the following is true of the drawing above? The triangle EGH has been enlarged to a figure which is twice its area. EGH. Okay. The equilateral EFGH has been reduced to a figure having half of its area. The triangle, which of the following is true? Okay. The triangle EGH and FGH are equal in area. EGH, and FGH. So the answer is C. They are equal in area. They have the same base and the same height. Once the triangles have the same base and the same height, they're going to be equal in area. If this line was extended all the way over here, and then a line left from H to a point all the way over here, and then went back to G, it would be the same area, as long as they have the same base and the same height. All right, number 59, two left. Which of the following drawings indicates the correct method of constructing similar triangles? Constructing similar triangles. Similar triangles, the correct method. It's C. It's C. This triangle and this triangle are two totally different triangles. Same thing here. These are two totally different triangles. These here. So this is a enlargement and reduction question. The only thing that changed is the dimensions, but the proportions remain the same. So the answer is C. And then number 6, it says item 6 refers to the following three views. The figures above show three views of a block: the front, elevation, end, and plan. Front, end, and plan. Okay. The front elevation, end view, and plan respectively are. Oh, what's the plan? What's the front, and what's the end? It shows three views of a block: the front, elevation, and end view, and front, end, and plan. What's the front? What's the front? Is this the front? I think this is this looks like a plan view. So all right, this is the plan view. This is what I see when you're looking down, so it would look like that. Which means that the front would look like this, because this is the opening here, so the front would look like this. And then the next side. So it's 1, 2, 3. And 1, 3. This is the plan. If this is the front, so that's there. 1, 3, 2, 1, 3, 2, 1, 3, 2. Number 60 is C. 2, 3, 1. Plan. What came first? Oh, the front came first. I thought the plan came first. So the front, this is the front, and then the plan, and then the side. So yeah, that's right. I was saying 1, 2, 3 because I thought that the plan came first here. So it's 2, 1, 3. Yeah. Good. All right. So remember to like the live, like the video. Remember to subscribe as well. You can share this video because the video is going to be on the channel, of course, after I end live. So you can share it with your classmates and so on, even after you leave. So, you know, they can come and watch the video before exams tomorrow. And also remember that you can also follow and subscribe to the Mr. Cargill channel that has other videos and stuff like that. And if you're interested in tutoring because most of you will be moving on to grade 12. Some of you might go on to university. But if you need go on to grade 12 and you need tutoring or help with BMed or any other subject, you may, and even university, we do tutoring as well. So you can subscribe, check the link, and you can head over to the Reach Educational Services website for tutoring and so on. All right, so good luck on your exams tomorrow. All the best. Please remember to subscribe as well. All right, so have a fantastic rest of your day and all the best with the exams tomorrow. Subscribe. Thank you. All right, goodbye, everyone. Have a good night.